Today on How It's Made. NASCAR car bodies. Curly sticks. Tube power amplifiers. And thermal coffee pots. The first stock cars were souped-up family sedans, but today they're custom-built for the racetrack. Each car body must match the contours of templates set by NASCAR, the National Association of Stock Car Auto Racing. On the racetrack, the shape of a car can give it an aerodynamic edge over the competition. So in NASCAR races, car bodies must have uniform curves. The regulations put the focus on driver skill and make the race a fair one. They mold some of the car's body parts from a carbon fiber and Kevlar material. First, a technician applies a release agent to a mold for the car's front end. Then he sprays a paint undercoat into it. This undercoat will eventually transfer to the completed panel. A computerized cutter slices the carbon fiber and Kevlar fabric into strips. It produces 22 pieces, each one cut to fit a different section of the mold. The technician rolls epoxy resin onto the fabric, one strip at a time. Once the strip has been completely coated, he transfers it to the mold. He tucks the fabric into the contours and smooths out any big wrinkles. He layers the strips 3 deep in a crisscross configuration for structural integrity. A coworker covers the carbon fiber with perforated plastic. They add layers of absorbent polyester and thick plastic, which they glue to the edge of the mold. They insert a fitting and connect a vacuum, which sucks out air and excess epoxy resin. The polyester material soaks up the resin as it flows through the holes in the first plastic layer. This both smooths and compacts the carbon fiber layers. Then it's into a hot oven to bake for 3 hours. This activates the epoxy and combines the layers of carbon fiber and Kevlar fabric. An employee removes the completed stock car panel and inspects it. Then it's over to a weigh station. At just under 8 pounds, the part is lightweight yet virtually shatterproof. Meanwhile, at another factory, work begins on the stock car chassis. They build it from square steel tubing that's super strong. An employee welds the pieces together to create a support structure for the car. At the next station, a worker forces narrow steel tubing against a spiral bit to carve notches in it. This tubing is for the roll cage, the structure that protects the driver if there's an accident. The notches will help form better joints. He grinds the rough edges, creating a smooth surface to weld the tube to the rest of the roll cage. Once complete, the team transfers the roll cage to the mainframe of the chassis. They tack weld it before doing the final welds. The next part is called the rear clip. It holds the fuel tank and has mounts for the rear suspension. With the car framework now complete, a technician scans it using a digital measuring probe. The scan confirms that the dimensions are correct. They now assemble the various steel and carbon fiber body parts to the stock car framework. They measure the completed car body by laying template grids on it. The biggest one sits over the center of the car. They pull a gauge through the gaps between the templates and the car body. The gap cannot exceed the tolerances set by NASCAR. They often must tweak the shape of the body part to meet regulations. Once the car has been painted, they apply headlight decals where the real ones usually are. Real headlights would add too much weight and pose a safety risk if they shattered. It's taken 3 weeks of intensive work, but this stock car body is now ready for the mechanics. Things are about to pick up speed. The game of hurling has been played in Ireland for at least 2,000 years. Players swing a stick called a hurley to hit a ball the size of a hockey puck into a net. Winning takes skill, quick reflexes, and of course, the luck of the Irish. Pass the ball and pass on the tradition. Hurling is a game that's older than the recorded history of Ireland. In Ireland, hurleys are still made the old-fashioned way, by hand in small shops. Ash is the wood of choice. They use only the part of the tree near the root because the grain flows in a natural curve there, making the stick less likely to break during play. The hurley maker slices the trunk into planks that are 1 inch thick. He'll make one hurley from each plank. He stacks the planks and then picks through them to select one for shaping. He scrutinizes the curve of the grain on the boards. It needs to be suitable for the size of the hurley he'll be making. His selection made, he places a see-through plastic pattern on the board. The transparency allows him to find the curve of the grain and position it within the striking surface of the hurley. He draws an outline around it with a pencil. After a rough cut and some initial shaping, he repencils the pattern and cuts it with a bandsaw. The striking surface of the hurley is called the boss. It's the most substantial part of the stick. He sculpts the stick to various thicknesses with the planer. He keeps it thick at the boss and thins it at the stem to give the stick some elasticity when striking the ball. This will allow the player to hit the ball farther. He sands the edges to make them more even. He tapers the boss to the very end, creating a sloped surface so the ball can be picked up easily. He then switches to a finer grit abrasive belt and sands the handle and the rest of the stick until it's super smooth. Next, he cuts steel banding to a length that's a little more than twice the diameter of the boss. He loops the band around the end of the boss and clamps it snugly to it. He drives large nails into the band to puncture it. He hammers smaller nails into those holes and all the way through the wood. He clips the protruding nails. He then flattens the cut ends to turn the nails into rivets. He folds the ends of the loop band together at the rim of the boss and nails them to the wood. Now securely attached, the steel band will reinforce the hurley at its most vulnerable point, the end of the striking surface. Not every player wants their hurley banded. This is an optional feature. He now winds rubber tape just under the handle for better gripping. He continues to twist it part way down the stick because players sometimes grip it there with both hands. He finishes the wrap at both ends with electrical tape, which has stronger adhesive backing. It will prevent unraveling of the rubber tape. It's taken about 20 minutes to craft this hurley stick. How long it will last is anyone's guess. There's no warranty on hurleys, and it's sure to break at some point because hurling is a rough game. Some players go through several hurleys in one season. It doesn't matter if you lose a stick, as long as you win the game. In an audio system, the amplifier is the component which makes the sound louder and sends it to the speakers. While most amps on the market are powered by transistors, many audiophiles swear by tube amplifiers, which use older vacuum tube technology. Many believe that tube amplifiers produce a warmer, more natural sound. This factory makes the amp's main chassis from a sheet of polished stainless steel. A computer-guided punch press cuts openings for the power switches, control knobs, and other components. The press prepares 8 chassis per sheet. Workers separate them with a few strikes of a mallet. Then they place them one at a time in a bending machine called a press brake. Once they position the sheet with the help of metal guides, they activate a foot pedal, releasing 90 tons of pressure to bend the edge of the sheet. Then they remove the adhesive film which has been protecting the mirror finish surface of the chassis. They clean off any remaining adhesive residue with alcohol. Then they put the chassis into an offset press. Using a silkscreen printing process, it labels the controls and connections. Next are the speaker terminals, which connect the speaker wires to the amp. These connectors are made of gold-plated brass, which are non-magnetic metals. Magnetic ones would react to the electric current and cause distortion. The terminal circuit board, installed next, carries the amplified signal from the main circuit board to the speaker terminals. They install and connect the power switch and the circuit board for the vacuum tube illumination. This indicates the tube's status. Meanwhile, this machine winds strands of copper wire around plastic bobbins to begin making the amp's output transformers. Output transformers match the amp's circuitry to the electronic specifications of different types of speakers. The number of wires, their different gauges, and the number of revolutions around the bobbin create this unique compatibility. After taping the wires to prevent unraveling, they join, then solder the ends to additional wiring. They will later connect to the amp's main board. A fiberglass sleeve insulates the connection. They place the bobbin in a lamination machine. Laminations are thin plates of carbon steel. The machine stacks them all around the bobbin. Then workers put a bolt in each corner to hold them together. They place the laminated bobbin in an aluminum housing and pour in hot black tar. This immobilizes the laminations, so they won't rattle when the amp is amplifying low frequencies. Then, workers install the two output transformers into the chassis, along with a third transformer to power the amp. They take the amp's main circuit board, plug in ceramic sockets for the vacuum tubes, and solder the sockets' leads to the board. Then, after feeding the transformer leads, they mount the main board in the chassis, screwing it to posts to hold it in place. Then they connect the transformer leads. They plug the vacuum tubes, one by one, into the sockets. The tubes are made of glass with a heat-resistant base. The interior contains a combination of metals, but no air, hence the term vacuum tube. The amp has 11 tubes in all, 7 small ones to power input signals from a source, such as a CD player, and 4 big ones to power output to the speakers. Then they attach the chassis' ventilated bottom cover made of painted steel. They affix decals to differentiate the output transformers from the power transformer. LED lights turn green when the amp is powered up and ready to deliver that warm, natural sound that many believe only traditional vacuum tubes can produce. People generally like their coffee either hot or iced, hence the need for the thermal coffee pot. Pour in hot coffee, and the pot holds in heat, keeping the coffee at that temperature for a good half hour. The trick to a thermal coffee pot is in the construction. Both the body and lid have a double wall, 2 layers of stainless steel. Between them is a tiny gap, just 5 to 6 millimeters. The air in this gap insulates the inner wall, trapping the heat inside the pot. They start with a stainless steel sheet, just 1.2 millimeters thick. The first step is to cut it into smaller pieces on a mechanical press. To make the coffee pot's body, they cut it into strips. Then each strip into squares measuring 8 by 8 inches. Then they put each square in another mechanical press. It stamps the square onto a circular die, which cuts it into a disc. They'll now use this disc to make the outer wall. They run the disc through a lubricator that coats the surface with oil to aid the next step, on a machine called a hydraulic deep drawing press. The machine's molders draw the flat disc into a 3-dimensional shape. This stretches the stainless steel fibers to a very fragile state. They strengthen the piece by what's called thermic normalization, heating the metal to 1800 degrees Fahrenheit, then letting it cool to room temperature. This process restores the original molecular structure of the stainless steel, so it can be shaped further without breaking. But first, they even out the jagged rim with the trimmer. Then they return the wall to the deep drawing press, outfitted with a differently shaped molder. The second drawing tapers the wall to a more rounded shape and forms a base to make the bottom perfectly flat. Then it's back to the trimmer, outfitted with a different tool this time to smooth the rim. They repeat the same steps to make the coffee pot's inner wall. The deep drawing press pulls the stainless steel disc into a slightly different shape, with the lip protruding to one side. They heat the wall in the induction oven to restore the molecular structure before shaping the metal further. Then they place the wall in a mold and release a press. This shapes the protruding lip into a spout. Then they transfer the wall to another press, which stamps it with the die, cutting off excess metal. They check to make sure that the inner and outer walls fit together properly. If everything's fine, they polish both walls inside and out. A little polishing paste applied with a sisal brush on the polishing wheel has the surfaces glistening in no time. The surface is now perfectly smooth and ready for welding. The first part they weld is the coffee pot's stainless steel handle. They shape it with 2 strikes of a press, then polish. They use a spot welder to fuse the handle to the pot's outer wall. Then they turn the wall upside down to stamp the manufacturer's logo into the bottom. Now the assembly. They place the inner wall on a fixture, then the outer wall over it. A press pushes the inner to the correct depth. Then they weld along the rim of the outer wall, fusing it to the inner one. The coffee pot's lid also has double walls for insulation. They weld a hinged lever to the lid and the adjoining part of the hinge to the coffee pot body. Then they gently hammer a pin through the hinge, riveting the ends of the pin so that it can't fall out. After a thorough cleaning in a dishwasher, the coffee pot is ready to use. If you have any comments about the show, or if you'd like to suggest topics for future shows, drop us a line at sciencechannel.com/howitsmade.